Before we start this video, a large thank you to Top, Michael, Brandon, Ascalera Official, Patrick, Ronald, Irish, very cool name, Ja, Milo, Olancy O'Reilly, Association Asia, Scott, Stuck, Loki, Dash, The Schemic, Sonny the Spaz, Jonah Andrews, Dom C, and Michael for their support on Patreon. I hope you guys enjoy the video. Hello everybody, welcome back. So today we're actually going to remove our rigid body control system. And you may be asking, why do I want to do this? Well, I've tried both extensively, and I've come to the conclusion that for this type of project, the character controller is better. And let me tell you why. Basically on the rigid body, we have to do a lot of stuff ourselves, and there's no problem with that, but we have to make a lot of little exceptions to rules during locomotion. For example, we don't want our characters to push other characters, so we have to make code so the character with a rigid body doesn't push another. We have to make our collider floating so we can go up staircases, so then we need to set our position based off of a strange ground check method. The list goes on and on and on. If we wanted to move our character to a certain position during, say, some kind of weapon art animation, it would get even more sticky there as well. So the character controller makes this a lot easier. You can actually just set if the character can go up and down stairs or not, and it will do it by setting a slope height and a slope angle limit. And furthermore, it cannot push other characters with a character controller on them. So it will get rid of that effect too. This means we can also delete our character controller collider, or character collision collider rather, and we can delete a whole lot of stuff and checks, and it just cleans up the code a whole lot. Now, if you do like using a rigid body, you don't need to do this. But if you're using rigid body and you find you would prefer a more simplistic approach, this is definitely the video for you, so let's jump in. Alright guys, the first thing you want to do is remove the rigid body and the capsule collider component from your player object, and all of your character objects for that matter. Next, we're going to add a component. Let's add the character controller, and this automatically puts a capsule collider on your character, as you can see. Now let's go down here and let's go to the combat colliders game object, and let's just delete it all. So we're going to have to unpack our prefab for that, but we no longer need this because we don't need a character collision blocker because we can't push characters anymore. So now let's go over to the character. Let's set up the character controller. So by that I mean set up basically the height, the radius, and the center point of your collider. So it's about as round as a person. You might need to play with the height and the Y position a little bit when you start in game. You might notice you might be in the ground a little bit or above the ground a little bit. That's okay. Just play with those values. All right, now that that's done, what we want to do next is to go to our player locomotion manager and open it up. As you can see, this is a very old script. It does not derive from a character base class, which we know by now is not too great if we share logic. So we're going to delete everything on the ground and air detection area. Everything except for the ground layer and the in-air timer. This move direction we're going to keep because we believe we need that. We need to keep the ground layer because that stays for the script regardless. And right here under handle falling, we're actually going to axe that entirely as well. Just let me look at my notes here real quick. So let's create a new script first, character locomotion manager, because the first thing we want to do, since our falling logic is going to be shared across all characters, let's put this on a base class. So let's call our namespace, and let's go to the AI locomotion manager and the player locomotion manager, and let's make this drive from the character locomotion manager. And I promise you guys, after this is done, you're going to enjoy this controller much nicer than the rigid body controller. You won't get stuck in corners when you're falling and stuff if that's happening to you, because I know some of that's a bit tedious to set up. The values have to be pretty precise. This will be a lot easier. So just axe the handle following method now, delete it entirely. Go to the character locomotion manager, and what we want to do is basically drag over our in-air variables. So I guess we can just copy all of these right here, the ground layer, move direction, and in-air timer. And then we can paste them over here on the character locomotion manager like so. All right, next I'm just gonna see what this normal vector is. Yeah, okay, so we don't need this normal vector anymore. That was for rigid body, and we don't need the target position for now, so let's just delete that, and we can delete everything inside the handle movement functionality on the player locomotion manager, except for the last few lines that just change the animator values. So you can see here where player animator.update animator values, keep those, and keep the checks for is interacting and is rolling. Other than that, we'll come back to that momentarily and repopulate that with new logic. So over on the character locomotion manager, we want to begin by making a public virtual void. We'll call it handle ground check. And this is just going to do as it says. If we're grounded, it's going to apply some logic. If we're not grounded, it's going to apply some logic. So we're going to start off by saying if the character, and we don't have the character called right now, so let's do that. We can say character manager, character and then call it on awake, and I don't have my namespace here, so it's giving me some grief right now. So let's add in our namespace. I forgot. Namespace SG. All right, and now we can just call that character whatever you want, and then let's call it on awake. Since this is a base class, we should make the awake a virtual awake, and then we should override it on the other classes and still call the base awake. That way, each awake method gets called. So if you're on the class that inherits this, you call this one and the inheriting class is awake. So let's change this to protected override awake, and then let's say base.awake, and then do the logic. Let's do this thing with start too, because just in case we ever want to make a start method on the base class. I'm going to delete the rigid body from awake on the player locomotion manager because we don't have it anymore. I'm going to delete the physics.ignore collision between the character collider and character collision blocker because we don't have that anymore, nor do we need it. And I'm going to delete is grounded equals true because we're not going to need that on start. It's going to be automatically selected if we are grounded on start. Okay, now back over on the character locomotion manager again. Let's do what we were just going to do. First, let's add a protected virtual void start, just so if any class has start, they can call the override. And if we ever want to give shared logic on start, we can do it here. Next, we say on the handle ground check method, we say if character dot, then we're going to say is grounded. Then we're going to open up some brackets and we're going to run some logic. Else, they must not be grounded. And then we run the alternative logic. All right, so we still need a few more things here to discern what we're going to do. So I'm going to make it neat and make some headers. Let's go just above here. Above the awake method, going to make a header and call it gravity settings. I'm going to put the in-air timer under that. That looks good. And I am going to make another variable here with a serializable field protected. So the classes that inherit this can read it. Vector3 y velocity. Okay. And then another serialized field, and then another protected, so the other classes that inherit this can read it. Float grounded y velocity, I'm going to say equals minus 20. And then we're going to have the starting in air velocity. So the grounded y velocity is the gravity applied to you when you're on the ground. The fall start y velocity is the starting velocity that applies to you when you're not grounded. That increases over time. So the longer you're falling, the faster you fall. So just to make that very clear, make a note. This is the force applied to you whilst you are grounded. So this is just a natural force pushing down on you when you're already grounded, just like gravity. And this fall start y velocity is the force that is applied when you just enter the air, and it will increase over time. So the longer you fall, the faster you fall. Next, I'm going to make a protected bool. So again, the classes inheriting this script can read this bool. Falling velocity set is equal to false. We're doing this because when we're in the air, we want to set it and set it only once. So this is how we're going to know, okay? All right, so now down here in handle ground check, we can write some more before we return and add a couple new variables. We could say if y velocity is, y velocity.y, is less than 0, we want to say in air timer is equal to 0. Falling velocity set is equal to false. And then y velocity.y is equal to grounded y velocity. So if we are grounded, we're not in the air, we set the timer, and then we don't need to set our falling velocity, so we set it to false, and then we just apply the grounded velocity. So the force pushing down when we're walking around the ground normally. If we are not grounded, however, then we're going to say if falling velocity has not been set, and it hasn't at this point, falling velocity set is now equal to true. And then we're going to say y velocity.y is equal to falling velocity at start. What do we call that variable again? Let me type in start. Fall start y velocity. Okay, yes. Excellent. Now, right below that, we're going to say in-air timer is equal to in-air timer plus time dot delta time. So for each second you are in the air, it goes up 1. Y velocity dot y plus equals gravity force times time dot delta time. And now this gravity force is essentially going to make it how fast you fall. So you can tweak this. I'm just going to make a float here, and I'm going to initialize mine as something random right away, maybe like 25 or 20. But again, you can play with this to see what suits your project the best. We'll say 25 at first. All right, that looks good. I think that should be fine now for the falling logic. We can add more to that over time as far as animation transitions. Go to the character manager now. And right at the top, make a character controller variable. Call it character controller. Every character in your game should have this if you are using the character controller method. I'm going to make it public. And then down here on the awake method, I'm going to call it at the very top. I'm going to say character controller equals get component character controller. This is why on your classes like player manager and AI character manager, you should call base.awake so you get this character controller even though you're using their awake method. Now, at the very end of handle ground check, we're simply going to say character.characterController.move, and we're going to pass our y velocity, which is just times dot. So we're going to pass our y velocity times time dot delta time, which is just a movement in the up or down depending on if we are grounded. Okay. Next, we're going to add a protected virtual void update. So if you have update on your player or AI character locomotion manager, please change it to an override update and call base.update. And then we're going to say handle ground check, and right above that, we're going to say character.isGrounded is equal to physics.checkSphere. And then we're going to say this is at the point of our character's transformed opposition, which will get us feet if you set up your game object like mine. And then we're going to say radius, ground check sphere radius, which is a variable we have not made yet, but we're going to make it a variable. And then we're going to check this on the ground layer only, okay? So let's go up here now and make this, and I have no idea how large this is going to be, so I'm just going to make a float. I'm going to set it to 1 for now, but I know that's most likely too big, probably by a fair amount, but we'll change that momentarily. We're also going to make a gizmo so we can see this, but first let's go over here and erase the ignore collision and the start method and the awake method entirely on AI character locomotion manager. We don't need it. If you are going to keep the awake method, you want to say protected override, and then you want to say base.awake like this. But because we're not, we can delete the character collider and character collision blocker too. But because we're not using the AI character variable here, you can just delete the awake method entirely if you want. Okay, back to the player locomotion manager to delete falling speed. Don't need that anymore. We do need the rest of these variables though. We're going to plug those back in. Okay, delete the character collider blocker and character collision blocker. Now delete the handle falling on the fixed update for the player locomotion. This is scenario 2. Save this. Now go back to disable collision. I think this is called when we walk through a fog wall. So we don't want to delete this. What we want to do instead, because this is an animation event, I'm pretty sure, we could say player.characterController.enabled equals false and player.characterController.enabled equals true. And yes, I can't find this in the code. So I'm 99% sure this is called on an animation event as we walk through a fog wall. So let's just say this. Player.characterController.enabled equals false. And player.characterController.enabled is equal to true. Wonderful. Okay, save that. Lovely. Go over to the game now, and let's remove our capsule collider and rigid body we can keep on the enemy. I'm going to drag this down. Okay, nope, I'm going to drag this down, and it does not want to drag down. Okay, there we go, finally. Let's set up the character controller again, and make sure you tick is kinematic on your rigid body, okay? Very important. So add a rigid body back to your player, tick is kinematic. And then we can untick use gravity, and you can freeze the rotation on the X, Y, and Z, but that shouldn't do anything anyway. Now back over here on the under handle ground check on the character locomotion manager, make an on draw gizmos selected. Gizmos.draw sphere, we're just going to draw our ground check sphere by putting in the same position as our ground check sphere in the update function, and then putting in the radius that we have, and then putting in the character.transform opposition, of course. I'm going to save that. That might give me an error, actually, because there's no... let's just see. No, okay, this looks fine. Make it 0.2. Yeah, definitely, because that is much too large one. So, okay, yeah, it's giving me an error. So I thought that was going to do that. It's because the character isn't called until the game starts. So instead of referencing the character, we want to reference the transformed opposition on the on gizmo selected. So yeah, that works. And 1 is way too big, as I suspected. So let's just say 0.22. You want to put it just outside the feet. That's very important. So maybe even 0.3. Okay, so we start the game here now, pause it, and drag him upward. He should plummet to the ground at the speed specified. So let's just make sure this works before we move on. Yes, it does. Wonderful. Okay, cool. So there's no animations yet, but we can set that up later. Let's go to the handle movement function now. Rename that to handle grounded movement. This is on the player locomotion manager. And I'm going to start writing some logic, and this is very, very straightforward with the character control. Let me show you. So we're going to say, if player is not grounded, return, because this is now handle grounded movement. We can have a different movement for when we're in the air if you want to allow that. We can say move direction is equal to player.player camera. I can't remember what I called that in this project. Maybe it's camera handler instead. Oh boy, let's see. Yeah, okay, it's camera handler. So move direction is equal to player.camerahandler.transform.forward times the player.inputManager.vertical input, okay? And then we do the same thing for the right facing side of the camera and the horizontal input. And of course, we're going to just come right below that now for the horizontal input. So move direction equals move direction plus, and we can copy this and just change forward to right. And then we can just change vertical to horizontal. It's very similar to before, honestly, except just simple, more simple, I should say. So I'll show you now just below when we're done getting the inputs here, what I mean by that. So we can keep our 3 original movement speeds, and we can say move direction dot normalize, and then move direction dot y is equal to 0, just like before. Now the first thing we check for is if we're sprinting. So right below that, we're going to say if player dot is sprinting. Then we are going to say player dot character controller dot move direction times sprint speed times time dot delta time. That's it. Now else we're not sprinting. We need to see if we're walking or running at full speed, and we can do this by checking our move amount variable on our input handler, because the move amount is a combination of forward and left or right movement, which averages out to a value between 0 and 1. So if our move amount is over 0.5, we know we must be running. Else it is equal or less than 0.5, then we know we must be walking if we're moving at all, of course. So this is very simple. Just copy and paste this movement code and replace sprint speed with, I believe is it run speed here? I might just call it movement speed because it's the default speed. Yes, I've called it movement speed here. And then down here, you would do the same thing, but with walking speed, okay? So just replaced sprint speed right here with walking speed. And that's it. So that should work right now. Let's save it and see. And yes, it does. Okay, so click in my game view here so the camera can catch up with me. But yeah, this is working great. But now you'll notice there's a jitter in the camera. And if you look in the scene view, you notice it's not my character. It's for sure the camera, because the character is moving fine, but the camera is jittering. This is because when we did rigid body movement, we put our movement on fixed update, which you're supposed to do. So copy that and delete it from fixed update and put it on update now, because now it's using a character controller, so it should be on the regular update method. And then we can, of course, save that and go back to the game, and boom, it's smooth, no jitter, looks great. Now, though, we have a problem if we roll or try any kind of action animation. It's not going to move us with root motion. But also, see how nice this is? You can go up these steps right now, and there's no wizardry needed for making a floating glider. You just go up them. It's great. So if you come over here now to on the enemy, do the same thing. Just set up your values as is per usual. Again, I'm putting this at 0.25, but usually do it at 0.3. I discovered this after testing this already, so I would make this sphere around 0.3 if your humans are the same size as mine. Go to the player animator or player animator manager on animator move. Let's make our roll move again, or make our actions move us again. Delete everything here because again, we're not using rigid body except for the top check for is interacting. Let's make a vector 3 for our velocity. It's going to equal the player dot animator dot delta position. That's it. Then we're going to say player dot character controller dot move, and then we're just going to simply pass the velocity given to us by our animation. Isn't that simple? Then we're going to say player.transform.rotation is equal to, or rather times equal to, player.animator.delta rotation. This will take the rotation of the animation as well, and you are good to go. So let's go to the base class and make this a base function. So let's delete it entirely from the player animator manager and copy it before we delete it. Go to the character animator manager, come right down here because this is shared by both the player and the AI. Let's on animator move, but let's make it a protected virtual void and paste this logic in here. Let's replace the words player with character, and now we have it working for both our enemies and our friendly AI alike and our player. Now, I think we have some logic here where we don't want to play the root motion rotation all the time for the enemy's AI. I can't remember why we do that. I just remember we do, so just in case, I'm going to check. And if you don't care about that, then don't check. And yes, it appears we do, because we have a check here for is rotating with root motion. So delete everything in here and call this as an override. Okay, so let's just say override right below the play weapon trail effects. And then call our on animator move, delete the base on animator move, and we can say, what was that called? If AI character is rotating through motion. Okay, so if we're rotating through motion, then we want to put the rotating bit in there and then keep everything else outside of it. So basically, it'll still work just like normal, But if you want the AI to only rotate with root motions on some animations, then that check will be applied. I can't remember why we do that, but I know it's important, so I'm going to keep it there. Okay, so let's copy all of the regular logic, put it on top, and put this logic in the brackets, and we're good to go. Save that, and I'm going to go back in the game. Make sure you apply your ground layer on all your characters again. It's probably got reset. And I'm going to delete detection layer. Don't need that anymore. I'm going to delete awake and the AI character manager. This is all an AI locomotion manager. Don't need any of that anymore. Okay, so delete the character collision blocker too on the AI, and that'll be good. And now I go over here, and you can see I'm going up this slope. And if you don't want that slope, if you think that slope's way too high, come down here and basically adjust the slope offset, okay? The slope limit is the angle that you can walk up before it'll tell you, no, you can't do that. And the offset is the height of the stair or the slope that you can jump onto. So you see if I'm at 0.2, I can't go up this. But if I gradually rise it, I can go up it. Okay, so not quite. I'm thinking maybe 3 or 4. And yeah, there we go. So you can go up it again. So you play around with that for your stairs. And you can't push other characters anymore, which is nice. And we can roll, and there is our locomotion back. So I still have a few more things to do with this, guys. I'm going to make it so we enter a fall state and play the proper animations, the proper landing animations, all that good stuff. But yeah, if you see it now, just fall off the edge. I can tiptoe off. You won't get caught on the side. You'll just drop. So I know some people were saying they were having problems with getting the check right, where like you would play the fall animation, but you'd be stuck on an edge without moving. So this should remedy all that. I hope that's clear for some of you, and I hope that helps. If you made it this far, guys, be sure to drop a like and leave a comment. It does genuinely help out the series so much. And I hope all of you are excited for the new series if you plan to watch it and absorb some of the netcode logic. And eventually, too, the netcode will be on its way over here. I'm going to do a few more polished things with the series, and then we're going to do a multiplayer refactor. So I will see you guys in the next episode. Have a lovely week.